Good afternoon, everybody. This is Nick Chalon. So thankful for you to be here today. We're going to have a great conversation with a lot of great people. So I hope you are ready for this. It's going to be a deep dive into what the Defense Unicorn has been building for the last 3 years now, I think, with a great team of people that know how to get stuff done. And we're going to do a deep dive first on the product, but also at how UDS is being used at the edge. It's going to be super interesting because, again, the edge is super different and complex. And I know a lot of you wonder how to get to DevSecOps and to modern delivery of software and capabilities at the edge, air-gapped, anywhere on any kind of form factors. So it's going to be super cool. So we're going to bring the team here first with Rob Slaughter, Austen, Bryan, and Jeff McCoy. Hello, good afternoon, everybody.
Hey, how's everybody? Can you guys hear us okay? I hear some comments saying folks can't hear us, but hopefully we're coming in.
Should be good. Should be good. Yeah.
Okay, awesome. Well, appreciate it, Nick. Thanks for having us on.
Yeah, no, thanks for being here. First, maybe we can do a quick intros. Rob, you go ahead, and then we'll go to Jeff and Austen.
Yeah, so Rob Slaughter here, one of the co-founders and CEOs, one of the CEOs, the CEO of Defense Unicorns.
Jeff McCoy, co-founder, CTO of Defense Unicorns.
You should tell a little bit about what you've done before. You had a life. I made you miserable for years.
Yeah, that's true. Yeah, that's we're trying to forget that. So,
I was expecting like bad mouthing me a bit. So
yeah. So spent 12 years in the military before I started Defense Unicorns. First half of that spent trying to use software for different military purposes, and then spent the second half of that trying to fix software while still in the government. Was either fortunate or unfortunate enough to cross paths with Nick, depending. Didn't have any gray hair before I met Nick. Now have plenty of it. And really kind of committed my professional life to solving this problem that we're going to talk about, which is how do you make software easy in some of the most important systems on the planet? And so came across Jeff and Austen, during my time in active duty, and excited to talk to you guys about what we've been building over, the last 3 or 4 years. And Jeff, over to you.
You have a PhD, which is,
I do. The only two people who call me Dr. Slaughter is Nick and my mom.
Right.
And so, but otherwise it doesn't come up very often because turns out physics and DevSecOps don't have a ton in common.
Jeff, over to you.
Yeah, so I was active duty for,
right?
Yeah, I was active duty for 17 and a half years, almost 18 years. And then I decided it'd be a great time to walk away from my lifetime pension. I spent a few months playing government and as a civil service person and realized quickly that, at this point in my life, I wasn't cut out for the politics. For which there was a lot. Nick, he likes the politics. For me, it just wasn't great. I just wanted to build technology, and so Rob promised me I could build cool stuff, and we could build open source things. And my passion's always been open source, and it's I didn't know how. I told Rob, I don't know how you make a business viable, but I just want to build an open source company in defense, because if you go look on GitHub, there just aren't a lot of those, or they don't exist at all. And so I think we've accomplished that, but it definitely was just kind of jumping into it feet first. In fact, I think Nick actually told me I was crazy at the time for joining Rob to go start a company. So I don't know. I recall that conversation, Nick. Yeah, other people thought I was crazy for walking away from my military retirement, but I think it was a choice, and I think that we have built something very unique and special here that's real and is solving real problems that I've been wanting to solve for many years and have been hoping somebody would, and no one did at this level.
But you forgot to mention you were a founding member of Kessel Run, Space Camp, and
Rogue Squadron and other things too. I did some software crap in the military too.
Yeah. All right, Austen, your turn.
Hey everybody, great to meet you. Thanks for having us on, Nick. It's good to see your face again. I also was, I mean, maybe. I was also.
Hey, you had the best Fridays of your life.
I also served in the military for about 11 and a half years. Had no intention of getting out of my secure, stable job for my family, but Rob, I think, texts me a unicorn emoji every day for about 2 days or 2 years, maybe just a year. Time flies. While I was in, I mostly did program office stuff. I did one space ops tour as well, where I learned how bad operational software is for the airmen at the time, which was very frustrating. And also, like Rob and Jeff, decided there was really nothing else that I want to spend my time on besides figuring out how fast we can update software to weapon systems, because that's really the strategic advantage. I helped start Level Up at the time, and that's where I ran into Nick. I was part of the Unified Platform Program Office at the time. I might have met Nick before Rob and Jeff did, actually. And then
I think so.
Yeah, I was struggling to do anything well, is how I would describe it, at my current job. And I met Rob and Jeff out in Colorado Springs at the time, and was like, these guys somehow have figured out what I can't figure out, so I'm just going to keep working with them, and kind of got swept up into the Platform One movement along the way. And then Rob convinced me to quit my job and come do this full time. So yeah, it's been great so far.
How many years you've been there now? 2? 1?
3 out of the 4 years the company's been there, I've been along for the ride. So
4 years DE already? Wow. Okay. I thought it was 3. Well, in place. Okay. All right. Cool. So maybe, I guess, Rob, do you want to give us a quick overview of what is UDS maybe, or how do you want to get started?
Yeah, I think it'd be good, just company background and perspective. And we've gone through multiple iterations on how do we explain the purpose of the company. And so how we like to describe it today is that we are on a mission to make software a strategic deterrent, which is a really big deal for me, because my background on active duty was a lot in the nuclear community. And so when you say strategic deterrent, that very, very much means something to a lot of different people, and it's a huge statement. And really what that means is, from a capability perspective, you have a capability that is so effective that your adversaries are ultimately afraid to start an engagement. And so what that means to us, if you look at the US military today, we see it as more and more becoming digital native. All weapon systems are software intensive systems these days. And we really see the country at a disadvantage when it comes to software, which is frightening to say as we look at everything going on in the world. And so we exist as a company to completely flip that. How do you take something that we feel like we're at a disadvantage with, because systems are infrequent to deploy, both from a capability perspective and as well as from a vulnerability perspective, and turn that into an actual advantage to where every system has the ability to update on demand? And that's really one of the things that we're excited to talk about today, which is the military really runs at the edge. The systems that actually go to war are edge systems. Even if you're connected when you start the engagement or about to start the engagement, you are not likely to stay connected throughout the engagement. And so how do you actually update on demand, not just at the tactical edge, but do that, while expecting not to be fully connected throughout the engagement? And so excited to talk about, UDS and UDS Tactical Edge. For those who don't know, UDS is our software platform, really built from the ground up. That's kind of one of the big ideas that I think the company has stumbled on, which is nobody makes a software product today, or very, very, very few people, and think about the defense community. And so if you think about the software platforms, we spent most of our careers struggling with the existing offerings that will come out with a solution. It'll get widespread adoption, and then the defense community would effectively be like a late add-on. Like, oh, let me get that phase 2 AFRIC SBIR so I can make, air gap an attachment to my system, or make accreditation an attachment to the thing that, we've already built. And so the approach we took was, how do you develop the software at a foundational layer perspective? How do you develop the software around the ecosystem to just make things kind of defense native? And so, Jeff and Austen and the team, developed a lot of open source products, things like Zarf and Pepper, if you're familiar with them, which really forms the base layers of what ultimately becomes UDS, which is a defense tech first software platform that we're excited not only to talk about, but to show you.
Who are your competitors? Who would you say can even come close to what you guys are doing?
That's a good question. I think there's several things in the ecosystem that do different variations of what we do. And so if you look at one of the core value propositions of what we do, one of the things we do for our customers is accelerate ATOs. And there's things like Palantir's Apollo and FedStart and Game Warden on the second front side that quote accelerate ATOs. But that's just like one of several things we do. What we also do is create baselines and systems that don't just accelerate ATOs, but are highly distributable across weapon systems. And when you start looking at, how do you accelerate ATOs? How do you become highly distributable? And then, by the way, how do you actually make that easy enough that a typical defense SRE in a classified environment or an actual warfighter or operator can manage the environment themselves? You eventually get to, there is no competitor that does all those things. And so the way I'd say it is, I think a lot of different platform solutions offer similar things to what UDS provides, but there's nothing else out there that offers everything that UDS can give, your mission.
Interesting. So where are you now in the UDS journey? If you had to rank your 1 to 10, right? And 10 being, okay, we built a stack that's now capable of running anywhere I gapped. Of course you can keep adding stuff, whatever, but how complex is it now, and how far are you from the initial target you gave yourself?
I think I think there's a difference between product maturity and distribution.
Right.
I think from a product maturity, we're there. And I think
Okay.
that's why we're doing these live events to kind of tell people we're ready. Like we've been using these systems ourselves for, onwards of about a year on very, very serious systems. And I think it's well tested. We're obviously still learning, but like I think the product is ready, and it's really a matter of distribution. So on the distribution side, we're just getting started. It's in a lot of systems, but not as many systems as need it. But in terms of product maturity side, I think it's ready for prime time. It's ready for literally any weapon system. We don't want to name the systems that we're on today because they're sensitive, but come have a conversation with us off LinkedIn, and we're happy to talk about it. Really, the point of this LinkedIn is to get the word out there and to talk to more mission environments, more PEOs, more programs, and kind of see what they're struggling with, because we know and suspect that there's a lot of people struggling with the problems that UDS was designed to solve.
Hey,
So I
Rob,
know you guys.
I'd mention
Yeah,
one
go
thing
ahead.
too, Nick. I think that where we're going, and what we're learning is, one of the things I really wanted, when I was a Govy, when I was in service, was like, hey, I have this other problem I run into as I'm using your system, right? It's this other like section of the pie that it's a problem for me and it's painful. How do I fix that? And often these systems are so large, they're targeted commercial markets. It's a multi-year process to like even start to see the benefit of some new feature coming in for that major system. And so like what we're finding with our delivery side of the company, as every time our unicorns are encountering new environments with new problem spaces, we start to define these new concerns, or they come from the mission heroes of new concerns, and we can start to react to those and start to build new things. And Pepper was actually came out of that as a need from one of our mission heroes, and so like we get to respond very quickly within a timeline of months, to build whole new feature sets and product categories inside of the UDS ecosystem. So like it's going to continue to do this and grow. And for me, if I were still in government, I have not seen anything. There is no other competitor, near competitor, or non-competitor that builds or produces new value in the same way, because we can target and rapidly focus really, really, really good, talented engineers on those problem spaces to buy them down at a clip that is significantly faster than our competitors and their competitors could even consider doing.
So Jeff, I know you wanted to show a little bit about the good stuff, right? Because talking is boring. So
It is
how
boring.
about we let you do some of that? I'm gonna move you up here and show
Cool.
us a little bit of the goodness.
Yeah, so we, one of the things, this is an example of this. So one of the things that came out, we talked, you did a live about this a few weeks ago too for UDS registry, but one of the problems, as I described, Nick, that we had was our delivery folks were saying, hey, we're hosting all of these artifacts, OC artifacts on GHCR, or in GitLab or other registries, And it's very painful to secure those, lock those down for the things we need to be a defense contractor, and then also allow IL5 environments, for example, to pull from them because we can't push those environments because it's a mismatch of authorization. So we have to pull from GitHub. Well, now your tokens are a mess, and it's a very big security issue with how tokens work in GitHub or GitLab. And so then we look at like what can we do? We could use Harbor, but as we all know, Harbor is a major consideration for the government because of the significant Chinese influence. So we're like, that's not really great for us either. We know that's a problem for some of our mission heroes, so we can't really use that for distribution. And this is a really big distribution problem. So we looked at other open source projects. We looked at Zot from Cisco, which is actually a pretty good tool. It's very it didn't meet our needs in a lot of ways, but it's a great open source project. I actually worked for a few weeks on that, building that out and seeing what it would take to fork it or evolve it to meet our needs. And it was more work to try to fork Zot to make what we needed versus just create our own. And so the problems we're trying to solve here is we need to solve the distribution problem for us to our delivery engineers and to our mission heroes. That is to publish artifacts and have them consume them. But then we also need to be able to give this to all of our mission heroes. So in their environments, in their data centers, and in their edge locations, they can push and pull and store artifacts as well. This is also kind of like the App Store model we talked about, or what we call it mission catalog within UDS. But the idea here is we needed a way to distribute software securely. And then we thought about like, what do we need from this? And one of the things we need for Edge is we need to scale down to almost nothing. So this is built off of OCI distribution, which is the core OCI library that every registry uses. But it can scale down to a single Go binary that can run with no dependencies at all on a system. It can literally run on a bastion, which is important to us because some environments we don't have a big, you know, Docker registry or OCI registry to move artifacts around. We have nothing. So we have to bring everything with us. So this gives you the same interface whether you're in a data center scale or if you're down to just a single instance. And so looking at this, like this is all published and automatically managed, but basically what we get is like that app view, but also we have the ability to kind of drill down into the vulnerability stuff, which is scanned. This one was scanned 13 minutes ago. We can look at the bill of materials. We can search across. So I'll go to an example here. Let's go back out to Mattermost to a newer one. I can search across like Iron Bank Mattermost 10.6.1, which was published a couple weeks ago. I can look at its SBOM and find what instances of curl are there across what images, and how they're affected. So we can see kind of how the image is built. We can see the layers that are built up from it, and we can drill down into different versions to compare them. So I compare that to the unicorn image, which is this one's based off of chain guard, and we can see its SBOM and how it's built up. We can look at vulnerabilities across all of this package because in UDS it's based off of Zarf, and Zarf packages have one or many images. And so for example, UDS core I think has like 24 images in it, and so we can see the vulnerability picture across the entire package as we bring it into whether that's Edge or data center or wherever it's going to go. Again, we can do all the same searching. We can find things, look at vulnerabilities, compare them across the various instances to see what's impacted, what those various uh, things are. We can drill into kind of like graphing through and understanding what type of vulnerabilities we're dealing with and how they're related. So like network attack vectors and how those relate over here to local attack vectors. And as we start to bring out the CVSS information, we can start to drill down deeper into what it is we're being impacted by. And so these are all just features. It's all live search. So I could search again for what are the vulnerabilities in curl, and I can see what those are and how they're affected and what images they impact, and the configuration for that and how that works. And so this is all just one thing that grew out of a pain point we had last fall. And then back in December, January timeframe, we started working on this to try to solve this distribution problem. And we quickly realized that because of the way that UDS is built, we can not only solve our mass distribution problem for the public UDS registry, we can also solve it for any mission hero. So they'll get the exact same copy, the exact same feature set, all the same scanning and ability to index, just like we have here. They will get that as well. So that's one problem we solved. The separate one, quickly, I'll show you. I'll pivot to is we also had to look at the problem of how do we deal with SRE work. So one of the other tools that we had to build was the UDS UI, which is it's a web-based dashboard and a CLI-based dashboard that gives us a quick look into the ecosystem that's running. And this is a cluster running in the cloud right now. It's a small one. but we can start to see what's deployed there, the various endpoints. We can start to monitor events and look at the security scans, see the various resources that are deployed and how things are running. We can look at very specific things that we care about, like UDS packages and the policy exemptions that are in place here. So we built this as well as another need that came out of um, it was a couple years ago now. Open Lens was a fork of Lens from Mirantis. Mirantis a closed source Lens. Open Lens was running, but then they fully like deleted the source code, so it wasn't maintained anymore. And our SREs were needing some sort of dashboard. And obviously, there's others out there we could use as well, but we wanted something integrated with our entire stack. And so this is another example of like we had this need, we had this problem we needed to resolve. So we just built it ourselves and brought it into the ecosystem. So now we have that as another tool in our tool belt to bring to UDS. I'll stop there.
That's impressive. So, how do you decide, I guess, when to partner with existing tools or build your own stuff? And how do you, make sure you're not getting too bloated or overwhelmed with too many things to maintain? How do you pick? Where do you put that line?
Yeah, we actually, and I think Dave's in the chat here too. Dave at VP of Engineering helps me a lot to steer kind of company policy here. But one of the things we always try to do first, because we're a big open source company, is to look for what's out there and what's available, right? If there's a tool that already meets the need and it's pretty close, we will do our very best to adopt that or partner with that organization to modify it to meet our needs. Um, One of the things I think, Nick, that you realize that you've seen as you've done a bunch of different companies is when you're trying to build tight integrations for good UX, like think the Apple way, right? It gets really hard to just take a random off-the-shelf tool and integrate it to have the same look and feel and kind of experience. And experience is really important to me. I'm 20 years of front-end development. That's actually my main thing was front-end engineering for a long time. I do this back-end stuff for the past few years because I have to, but I actually love building UIs and building compelling things. And we love to integrate tools when we can. For multi-cluster observability, we're looking at different scenarios for how we do multi-cluster distribution and observability. And so we'll look at those as well. And the whole idea here is like everything I've shown you, UDS registry, the UDS UI, those are all API driven, right? So the intent here is like, yes, there you see this, but also it's an entire API you can run, and you can go and check all of the different endpoints and build something custom yourself as well. So there's other options to. I mean, it's a pretty large API that you can run through, but the point being, like we build these things API first, so that we ourselves can consume them. So, for example, the UDS registry today does not serve the security view of UDS UI, but we're migrating it to that now. So the UDS registry will do the scans. It will produce an API endpoint. UDS UI will use, and then our partners, SAIC and others, will have the ability to take those API endpoints and integrate them into their own tool chain, however they want. So we always want to use open source if we can and support it. But sometimes we just can't. And I think the biggest one that people ask about is Pepper. So Pepper was an open source tool we built. It's a TypeScript SDK. It lets you build simple, fluent API based plain language policy or code that has full type safety. And you can build full operators from that, which the US operators built in Pepper. You can build full webhooks, mutating, validated. We literally replaced all of Caverno with a few lines of Pepper that ChatGPT generated for us. So we were able to build in, and this is important because it's TypeScript, you can tell an LLM, right? This is TypeScript. Follow the conventions of TypeScript. Here is the SDK. And the LLM can say, oh, okay, I know TypeScript. I know these conventions, and it can build that out. And that was an interesting concept for us that we've seen over time grow. And you can go to pepper.dev for more information. But the big idea here was like, how do we make this a system that is more accessible to build very complex things, write plain language things, and turn it into the things we need to validate, to mutate, to operate. And so Pepper came into this as one of those tools that just made a lot of sense for us. It was way less resources. It was accessible. We made it an Apache 2 thing. We want to donate this to Foundation. And that's just kind of like, we won't always build our own thing, but we'll absolutely always evaluate and assess what's out there right now and can we use something else.
That's pretty cool. Pretty cool. That's a lot, obviously. So someone, I don't have the name, but someone had a question, right? Is his entire universe is C2, right? So he's trying to understand how your UDS capabilities overall would help him support a C2 DevSecOps cell.
Austen, you want to take this one?
I'd love to. Rob and Jeff usually create the chaos, and then I'm just here to organize it. So I was waiting to see, who wants to answer first. I assume C2 means command and control in this aspect, but I think we hear from the DoD missions quite often is what I'll call a hub and spoke concept, where within the firewalled or air-gapped network, there's some sort of C2 node where they have the main set of operators who want to then manage all the different spokes in their environments. You could think even drone swarms with a C2 node or anything else like that, or even just IT systems where you have maybe one major cloud environment and then a bunch of on-prem things across either the continental United States or maybe outside of it as well. And one of the big features we are working on actually this year for UDS is what we call multi-cluster observability, which is actually a harder problem than I appreciated initially. But how do you look into other, what I'll call subordinate environments from one main one so that you can manage your staffing appropriately? Right now, UDS does not do multi-cluster observability, but Jeff promises me it will this year, which is the fun that I get to work on with him all the time. So I think as far as the DevSecOps side of it, though, I think of that more a lot of times of like, how do you deliver software into that area? Like UDS is definitely built for that out of the box. I often just refer to it as a software delivery platform. So how do you get commercial and open source things from where it was ever created? That could be somewhere on the internet, a vendor environment or whatever, usually picking up containers and Helm charts and deploying it into a different environment. And that's really what UDS was created for. And it's fundamentally built on Zarf, which Jeff covered Pepper, but Zarf is the longer standing open source project that we have. Actually has been donated to OpenSSF. It's actually a really interesting backstory. There was also a question in chat, so I'll just get to it too while we're on Zarf. But Zarf was created in partnership with the Navy on a cyber contract. The cool part of it was instead of the company, retaining all the cyber data rights that you could have with that, it was actually donated to Foundation in coordination with the government. So all that copyright, intellectual property given away, we actually get a ton of people reach out to us about Zarf. Zarf is a way to do air-gap things, but we built a product UDS to deliver software with Zarf where everything is air-gap-native. And I think sometimes those can be people reach out to us not knowing the difference between the two. UDS is a platform that brings a bunch of technologies together that are all built on Zarf Zarf air-gapped native containers, whereas Zarf is a tool where you could technically air-gap just about anything. So two very different things. But yes, to the DevSecOps side of like getting things continuously into your environment. How do you manage multiple end nodes from a kind of a central point? That's a little bit of a harder challenge. It's on our roadmap this year.
Cool. So what else do you want to show, Jeff, to the world here on the product side before we start looking a little bit at the edge stuff?
Yeah, I think on the tip is Edge, which Rob I think we'll be sharing. So I mean the biggest thing for us is like UDS is an ever evolving thing. We're going to continue to build more technology very quickly with world-class engineers, and so there will be plenty more updates in the coming months.
So when you deploy UDS, what if you start from blank, right? What do you end up with?
Yeah, so there's
what the big buckets, right? What boxes are you checking in DevSecOps by deploying UDS?
well there's one that's a funny discussion about sidecars, but we thanks to somebody's reference architecture they wrote a few years ago. But I think overall like we believe that the tendency of idempotency, of building declaratively, of having hermetically sealed build environments and building securely and automated, using CI for everything, continuous delivery. All these pieces are important for us when it comes to specifics of like what the DoD thinks about what DevSecOps reference architecture. That's a bit of a special sauce there. There's a lot of debate there in the community, as you know, Nick. For us, the things that we bring to bear are the things like a service mesh. So today that's sidecar based with Istio. Through the UDS operator, we're actually converting next quarter. So the baseline will be ambient mesh, which will be sidecarless service mesh. What that means is it reduces the baseline memory requirements from 50 megs per pod to just a couple megs per pod, which is significant. So we need that for Edge, frankly. We need that for our very small compute systems. But you'll see service mesh. you'll see integrated IDAM. So one of the things that we have as well, and you can go to the UDS website for more about this, but we have integrated key cloak in a way that you can literally just define a couple lines in the operator CR, and it will auto create clients for you in SSO. It'll auto wire them. It'll auto protect them. And some of this work is stuff that I wrote originally back at Platform One. I rewrote it for this because it was pretty old. It needed some TLC. So we have the automated wiring for authentication, for identity. So you have full auth auth-in, the service mesh, of course. And then one of the other things we like to do is we do like a default deny. So one of the things as you roll applications out is every pod by default is firewalled effectively. And this gets tricky, by the way, in ambient mesh because there's new restrictions there. We had to work around that because ambient mesh doesn't work with net policies out of the box in Kubernetes. So you had to be more creative with Istio policies, but we've done that work now. So what you get is you take your application, whatever it is, you bring that into the environment with basically one CR, the UDS operator CR, and it does all the wiring for service mesh, for authentication, for authorization, for network policies, for events in depth. All those mappings are provided for you. And then as we make changes or iterate, you get those as well. So as we transition from Istio sidecar to Istio ambient, the users won't have to change their workflow at all. It'll be the same CR. The operator will manage the upgrade for them, and they'll just get the benefit of this drastically, substantially reduced resources for them. So that's like, it's really like in the operators where most of the magic happens. The rest of it's kind of supporting functions to get there.
Very cool. All right, so I think it's time to talk a little bit about Edge. So let's dig into it. Is that you, Rob? You're going to share your screen, or how you want to do
I think just we did release a video. We'll have somebody in the chats link it there. I think there might be audio issues on us sharing it, but just to talk through the issues of Tactical Edge and why we have such a focus there, and that's really because the majority of projected power capability that we have as a nation is really on the tactical edge systems. And so, and the definition of tactical edge is very, very broad. And so kind of to even start there is if you go talk to somebody, they'll tell you tactical edge is a small drone. You go talk to somebody else and tactical edge is this large ship with these server racks because their edge is just deployed anywhere at sea. And so but the reality is edge is actually where the warfighter is where the majority of capabilities are. Community, I think, has gotten okay at continuous cloud deployments once an ATO is established. And so UDS helps establish that ATO faster and then make it easy to integrate once and deploy anywhere. But we were still predominantly focused on on-prem and cloud deployments. What we announced recently, as from a company perspective, that we're super excited about is UDS Tactical Edge, and what that means to us is how do you bring all those same capabilities that we have been bringing to the cloud, we have been bringing on-prem to really edge, as defined from everything from a drone, which we released that YouTube video, so please take a look. But edge could also mean, like I said, that ship. It could mean that on-prem system that happens to just be overseas. And so it's recognizing that not only does the compute matter, but it's also acknowledging that the experience level of the user who has to maintain the software, you have to actually abstract the complexities. And so there is a ton of this is the issue with the DoD, which is there's a ton of cybersecurity and a ton of compliance complexities added to the stack. And so, Nick, helped author the DevSecOps reference design, which was great. Really got the DoD focused on this is what it means to do continuous delivery. But oh my gosh, that tech stack is super complicated. So if you've ever tried to deploy something that actually adheres to the DevSecOps reference design, good luck. It's very, very difficult. So what we did with UDS is actually just make it easier. And also from a layer perspective, actually make sure that those deployments can go on successfully. And how do you actually get the operator themselves to manage those deployments? Austen, did you want to add some thoughts on the justification to edge and why UDS went that way?
Yeah, I know. I kind of want to tell the Genesis story too before Jeff talks more tech, because I think it's a cool story worth sharing. I think, for all of us that served previously or intimately familiar with the mission, like the concept of DevOps is great, but continuously deploying to cloud doesn't really help the Department of Defense that much. There's obviously some missions that live there, but on-prem, even private cloud or classified cloud, only gets you so far. The mission needs is really, people on foot or on a boat somewhere, typically by themselves. And I think that's the thing that makes Edge the most unique when you talk about it from a pure product perspective. Like, what is the problem we're trying to solve is, people are tired of shipping IT admins or software professionals with their software updates. And a lot of times you can't even send them with it. And I think the proliferation of drones has really even highlighted that problem. Like, hey, I got to send my software expert to all these different austere locations just so I can update my software, either for critical security reasons or for new features or capabilities to respond to the mission. And so the question we really had to ask ourselves is, how do you deploy software without an IT professional in the loop anywhere? And I think that is a challenging user experience to tackle. And Jeff will get into some of that. But the cool concept of, like, I think is interesting with defense unicorns, and you hear the concept of forward deployed engineering talked about a lot now, is really meeting the mission where it is and being willing to like build something that maybe you only partially keep for the first part, and then you iterate on and be able to make high kind of ROI decisions for the mission after the fact. Two of our awesome unicorns were out at a hackathon hosted by the Air Force in Hawaii. Somebody was wearing a Zarf t-shirt, which is our open source tool I spoke of earlier. And they said, hey, what do you guys know about Zarf? And they're like, oh, actually, our company created Zarf, which led to a conversation and emails and phone calls. And eventually a couple engineers, as they lovingly call it, getting nerd sniped into a challenging problem of updating software onto an aircraft. I bring that up because it was always the vision, I think, for defense unicorns to solve problems at the actual tactical edge, right? Where the mission actually happens, like on the actual weapon systems. Which, what does that usually mean? It's some sort of embedded system that's running like an i7 as far as like compute goes. It's not, Jeff talked about how do you take something and shrink it down to just the cybersecurity parts you need with the application on something with a very small compute footprint and storage footprint. And that's really, and then do it without an IT professional, right? So talk about an interesting technical challenge. I think that's the problem we set out to solve. And it's all about how fast can you deliver value to the mission. And I think we've been able to accomplish some things that, back when I was just a lowly captain, thinking about this problem in 2018, probably, I honestly didn't know if it was possible, especially because of all the hurdles that Rob brought up. But with the right technology and team and partnerships too, just about any of that's possible. So I think, Jeff, you want to are you walking the team through next what they were able to build?
I have some comments, but I'm not going to the demo right now for that. We already have a couple of ones we did link a lot of videos ago for the actual demo. But one thing that comes up a lot is, we have the Android app for Tactical Edge for software deployments, and the design there is really for that end user who's not technical to be accessible. And this goes back, Nick, to the API-driven systems. Like they're consuming the same APIs that I mentioned earlier. So like as we build the ecosystem, well, now we need a view that works in an Android tablet. Well, cool, we leverage the APIs and we can, here you go, here's an Android app, right? So that's part of that evolution of like, what is the endpoint that makes the most sense for the user and what do they need? But then also like when we talk about being declarative and how are you declarative if you're using an app is a question that comes up a lot. And so one of the things that we've learned is like Zarf packages themselves are this kind of sealed artifact, right? They're a sign, they're an SBOM artifact, they're a thing that you have a known quantity of that's declarative that you can roll out to different environments. You build it once, you can deploy it many places. So that in and of itself gives us a level of declarity, and I think that Wayne said it last time in the Edge chat. He called it, I think he called it OCI ops. We've heard of GitOps, but OCI ops is a term that I hadn't heard before Wayne said it, but it makes sense, and it's a trend we're seeing. We're seeing more and more systems move towards making the registry the source of truth. I mean, Helm's done this, Flux is other many tools have actually done this. We just don't always say it. And what that really means is you have a build system where you produce all of your provenance and your signing and the artifacts you need for security and for your GRC requirements, and then that produces an artifact which publishes to a registry. That registry can do more. It can now scan, it can assert trustworthiness, it can validate things like signatures or do ClamAV. Think like back to Iron Bank, right? it's taking the Iron Bank idea of a trusted source and making it everywhere, but backing it by provenance and backing it by process and not just by a single entity saying, trust us, we have this. It gives everyone the ability to see more deeply in their environment for their systems how they can do this. And so I think like that's one of the things with being declarative in Edge is one way to look at this is you take the entire stack and you deploy it all at once. That's a great way to be declarative. That's what we did for Bridger and the Bridger project back in 2021, whatever it was now when we first built Zarf. It was literally just like an entirely declarative package. You start with that. That's how Zarf was created. Take the entire ecosystem and rebuild it all at once. That's a way to do Edge. You can also do it through OCI ops, so as a way to say, okay, all these things are part of the declarative bundle. And then lastly, you see this obviously with us in cloud, we're starting to trend more towards like IAC, Terraform declarative stuff. So working on a tofu provider for Zarf to and UDS to roll out things more declaratively in a more scaled, manageable way for like, for the larger system. So I think what I see here is just more of this like tailoring to the right type of endpoint, the right UIs, the right deployment strategy, but still maintain the truth of like being declarative, not just click ops, being true to ourselves as far as how we roll things out predictively so we can roll them back over.
Yeah, and want to highlight from a capability perspective, like one of the reasons why I'm ridiculously excited about UDS Tactical Edge. No matter what weapon system you're working on today, you have limited compute. And the definition of limited compute kind of changes system to system. But what we have the ability to do with UDS Tactical Edge is define your software update based upon mission requirements. And so, as mentioned, my background's in the Air Force. You ever, flying with, an F-22, F-16, like your mission requirements determine your munitions. As an example, and you can only bring so much with you. So like an air-to-air mission is different than an intelligence mission, is different than an air-to-ground mission. And I'm guessing both now and in the future, your software should be different as well. With UDS Tactical Edge, you'd have the ability to determine and define the software that you go to war with for mission-specific requirements. We think that's a huge deal. Obviously, if you're on this chat, you're probably using AskSage or, at least interested in it. I know Nick is talking about and doing Tactical Edge deployments. With UDS Tactical Edge, what we would be talking about from a mission perspective is, if you tried to deploy all of AskSage on the edge, that's going to probably be a pretty difficult deployment. I think Nick will tell you that from a capability perspective, you're going to get better responses from access to a cloud API, but it doesn't mean that your mission wouldn't need a tactical edge deployment. On that tactical edge deployment, you're going to have to be very specific with what you're trying to get. And it might change day to day. It might change hour to hour, and you're going to have to be able to update your system as your mission requires it.
And, I think that's where this is going to be incredibly powerful, right? Because if you can bring any apps, and AskSage is just one of many of your store. How do you call it? Store? Is that a store?
Yep, the AirGap App Store.
AirGap App Store.
Yeah.
So that is, any company can work with you, right, to get on the store. You already have a bunch of open source tools as well. And so now you're giving access not only to all these air-gapped environments, whether it's on the cloud or not, but also at the edge with the same stack. And so that is, I don't think there's anything else like this, right? Everybody else that helps accelerate deployments is usually on clouds. Nobody is doing it at the edge or, true on-premise, right, for weapons. So pretty cool. And yes, AskSage would like to be part of that for sure. Cool. So what are we missing? What did we not talk about? A lot of discussions. I was reading the chat here. But what did we not share yet? Well, how do people get involved? First on the UDS side. What about Edge? How is it going to work when it comes to hardware supported and that kind of stuff?
Well, if folks are interested, just reach out at hello@defenseunicorns.com. There's certain things that on the LinkedIn Live we don't talk about, can't talk about. But if, the right government folks would love to have a, more thorough discussion with you by just going to hello@defenseunicorns.com. I think from, our perspective, and one of the things I'd actually love to talk with you, Nick, is how does AI run at the edge? AI has a whole level of complexity beyond just, typical compute requirements around what it takes to actually be successful from a mission perspective. And so like it goes beyond just making the deployment successful. You really, really come into real limitations, especially in defense, because not a lot of folks have GPUs. And so, from our case, we're getting more used to AI deployments. I'd say the number one use case that we're looking at for future edge deployments is on the AI side. So I'd love to pick your brain a little bit, Nick, on, both what Ask Sage is doing and what you see the community is going towards. But I think what the defense community is going to have to kind of open up with and realize is an already terrible situation around how do you adopt modern software is about to get a whole lot more complex once you add in AI, which at the end of the day is just, more software. But on the AI side, you have an additional layer of complexity on the infrastructure and the compute that I don't think you're, struggling with as much as you were with like cloud native applications 2 and 3 years ago.
So a lot of people were asking me on the chat here about hardware, like how much can you scale, I guess, and are you going to bring partnerships with teams like HPE or Dell or that kind of stuff, or are you going to have other options? And can it horizontally scale, Jeff, or or Rob, whoever? What makes sense, I guess, for hardware?
Bobby, who is on the thread right now, is the right person to handle it. We are very much looking for partnerships on the hardware side, also looking for use cases. And so, like, to go back to the first question, or one of the first questions you asked, Nick, which is like, how ready is this? From a technology perspective, it's very ready. It's, in use today. It's ready for production. It is in use in production and sensitive environments today. What we're looking for is distribution. We know it needs to get into more places. We build technology to purposely be infrastructure agnostic. As mentioned, when you add AI to like the capabilities that you're deploying to, that definition of being infrastructure agnostic becomes a little bit more complicated. So you have to start forming some opinions around those deployments. And in Bobby, who's on the thread, is the actual VP and GM of our UDS Tactical Edge work, and is excited to talk to whatever hardware teams are out there today, or mission teams looking for hundreds to thousands of deployments.
So you've not yet partnered with a Dell or HPE, but you're open to it and you're looking for partners, right?
Correct. Yep.
Okay.
Yep. And we do.
But it would work on the HP Edge Line 8000, all that kind of hardware. There would be no issue running pretty much anywhere. So makes it easy. Okay.
Yep. And
Yeah, I
Jeff,
think one of the things we really Rob and I talked about this morning actually again, but we've been focusing on building for a variety of different hardware platforms or technologies, and obviously there's more to drill into in that space, but we're trying to focus a commonality and stack. Because I would describe everything not exactly how Rob described it as it's not all products in the same sense because there's levels to that. The UDS core has been tested thousands of times for a year. The other layers, they're newer, right? So I always like to hedge a little bit and say, well, okay, UDS Registry, for example, is very new, but we're using it now, but we're still just testing and phasing it in. The point is, like, if you can make commonality with your edge and your data center, if you can make them the same, you now get the instant benefit of you tested this thousands of times or hundreds of thousands of times already with many diverse environments. So that's what we focus a lot of energy on, is like, how do we make the edge stack behave the same and operate the same as the same layers, we call them functional layers, common layers, as data centers, right? And as larger scale systems, and just do scaling, whether that's horizontal or vertical scaling. And so I think we've done a really good job of like finding that happy middle ground. Because one of the early questions is like, do we need two different stacks? Do you have to have two different technologies, one for edge and one for cloud or for data center? And we went down that exploration and realized that if you're very careful and you think through it well and you think about scaling well, you can actually bring them to unification, which, even though our edge stuff is still just newer, it's still a few months old now, it instantly has the benefit of having that whole year of testing and validation, all those other environments. So we have a lot of interesting value there when it comes to hardware. I think, and Bob goes to this as well, is like we start by partnering with the mission needs. So like we may find a partner in some, mission system or weapon system, and they may have a company we partner with for that. But like when it comes to long-term hardware play, I think for us, we want to be able to support generically whatever the mission needs. And like some may have contracts with HP, some may have contracts with Dell, and we need to be able to support both. And we haven't tested all those completely, but we're building with on multiple OSs and multiple deployment models that allow us to kind of flex with the demands that we have, which is like back to Zarf. Why was Zarf so unique? It's because we took a problem that hadn't been solved before, which was how do you bootstrap a Kubernetes cluster for air gap when it's not made to do that? So we built a tiny Rust binary to go and inject itself into the cluster and self bootstrap. And it's that same concept of like, how do we start this edge deployment when we don't have like the things we need in place already? And it's just kind of you roll out the pieces you need first, and then you use those same pieces to build itself up.
Perfect. Well, I think this was a great deep dive. I think we answered a lot of questions. How do people reach out to you guys if they want to start engaging?
Can go to the website, defenseunicorns.com, or just shoot us an email at hello@defenseunicorns.com, and we'll get back to you. As mentioned, defense tech company, so you can imagine a lot of the stuff that we do is sensitive, even though a lot of the work that we do in technology is in the open source. And so if you are a program office, on the government side, or you're, a defense prime or a small startup looking to work with the government, we'd love to talk to you. In the right channels, we'd love to talk about more details.
All right. Any last words? Anything we forgot?
No, just thanks, Nick. As always, appreciate everything you do for the community, and appreciate your time.
No, this was great. I think a lot of people learn a lot of what they're going to take a look at UDS and running at the edge, and bringing new apps on it, and completely changing what's possible with our warfighters, which is all we care about. So thanks, everybody. You be safe. If you have any questions, feel free to put in the comments. I'm sure we're going to take a look at those. And you keep pushing, and make sure you continue innovating, and don't give up. I know it's a stressful time now with all what's going on with the new administration and Dodge and all that, but don't give up. Thank you, everybody. Stay safe.
Thanks.